Yes, good morning everyone. So, this is Shakila, Department of Physics. We discussed about in previous classes about scattering of light. So, already you know very well. So, what are the two types of scattering? One is elastic scattering and other one is inelastic scattering. So, what is elastic scattering? The incident beam and the scattered beam, it will be same, means we called as a elastic scattering. Okay. And next, what is inelastic scattering? The incident beam and the scattered beam is not same, means we called as a inelastic scattering. So, what are the four types of scattering we discussed in last video? So, Rayleigh scattering, Mie scattering and Raman scattering and Tyndall scattering. So, in this video we discuss about one by one. So, first, what is Rayleigh scattering? So, scattering is you know very well, when the sunlight is passes through the atmosphere, it will be spreads into all directions, we called as a scattering of light. So, what is Rayleigh scattering? So, Rayleigh scattering is nothing but the law states that the amount of scattering of light is inversely proportional to the fourth power of its wavelength. Fourth power of its wavelength. So, we called as a amount of scattering is inversely proportional to amount of scattering is denoted as S and wavelength is denoted as lambda. So, it is inversely proportional to fourth power of its wavelength, means we can write S is inversely proportional to 1 by lambda power 4. And next thing, according to this law, the shorter wavelength colors are scattered much more than the longer wavelength colors. Okay. So, longer wavelengths are one of the example for we have to consider when sunlight is passes through the atmosphere. Okay. So, the blue color is scattered to a greater extent than the red color. So, this is the reason to sky to appear in the blue color. So, what is the reason to appear the blue color in the sky? Due to the reason of Rayleigh scattering. And next we will move to Mie scattering. So, Mie scattering is one of the example for inelastic scattering. So, it is nothing but it causes by and pollutions and dust particles, smokes and water droplets and other particles in the lower portions of the atmosphere be scattered in all directions, we called as a Mie scattering. And next one, Tyndall scattering. So, what is Tyndall scattering? When a beam of sunlight, we have to consider when a beam of sunlight, it is enters into the dusty room through the window. All of can observe this type of scattering. When we are opening the window, we can dusty rooms. So, the sunlight is passes through the dusty room through the window, it becomes visible, it is become visible to us. So, this is because of the tiny particles. So, tiny dust particle present in the air of the room scattering. So, this is called as a Tyndall scattering, and one of the example for Tyndall scattering, the scattering of light rays by the colloidal particle in the colloidal solutions is called also Tyndall effect. We called as a Tyndall effect. And next one, Raman scattering. So, it is mainly depends upon the frequency or wavelength. So, what is the concept of Raman scattering? The scattering of light contains some additional frequencies or wavelength other than the incident frequency. You know very well what is the inelastic scattering. The incident light and scattered light is not same, means we called as a inelastic scattering. So, the Raman scattering is based on the principle the frequency is greater than the incident frequency or incident beam. So, this effect we called as a Raman effect or Raman scattering. So, what is the concept of Raman scattering? The Raman scattering is defined as the interactions of light energy with the particles of pure liquid or a transparent solid, which leads a change in wavelength or change in frequency. So, it is mainly depends upon the change in frequency or change in wavelength. So, we called as a Raman scattering. I hope all of you understand the three types of scattering, Rayleigh scattering and Mie scattering and Raman scattering, and last type of scattering, that is a Tyndall scattering. So, and next we will move to lenses. All of you know very well. So, what is the lens? It is a transparent material, it is a transparent medium. So, what is the purpose we are using the lenses? To optical purpose. A lens is an optical optically transparent medium bounded by the two spherical refracting surfaces or one plane and one spherical surface. You know, in previous topics we discussed about the incident ray, reflected ray and refractions. All the terms we discussed about in first video, optics class 10, first video. So, based on this we can explain a lens is an optically transparent medium bounded by a two spherical refracting surface. One is plane medium or other one we called as a spherical medium. So, and next we classified into two types. One is convex lens and other one is concave lens. So, lens is classified into two types. So, first we discuss about the first lens, convex lens. So, what is the other name of convex lens? It is a biconvex lens. So, it is a lens bounded by two spherical surfaces and it is a thicker. So, the center part it will be a thicker and a beam of light passing through a converged to a point. So, converged to a point. So, that is why we called as a convex lens is a converging lens. So, converging lens, all the light rays is converged meeting at a one point. So, we called as a convex lens is a converging lens. And next one is concave lens. So, what is concave lens? Other name of concave lens is a diverging lens. So, how to be called as a diverging lens? All the light rays, a parallel beam of light passing through any point, it will be spread or it will be diverged. So, that is why the concave lens we called as a diverging lens. So, what is the constructions of this concave lens means? It is a lens bounded by two spherical surfaces. The center part is look like a thinner. Convex lens is look like a thicker and concave lens is middle part it will be a thinner. So, we can identify this is a convex lens and this is a concave lens. And next we will discuss in next video. Thank you.